Alright, we're going to continue with Rules of Replacement 1, Section 7.3. I've got 3 more examples, so let's just jump right in. Here we have 2 premises here, and as we start with all of these proofs through natural deduction, we're trying to get an L. Okay, I see the L there, so we all already know, we've done a lot already, that the way to isolate a consequent of a conditional is to get this antecedent, okay? So we need a disjunction either G or K. If we can get an either G or K, we can get the L and we're home free, all right? Well, I'm seeing a J up there, and I know with distribution, I can turn premise 1 into a conjunction, right? H or J, and because it's a conjunction, I can bring down the G, right? So with distribution, I see the G, I can get that isolated. There's no K anywhere. The only way I'm going to get the K is I'm going to have to add it in. So let's do distribution on the first one. We get both G and either H or J, right? So that would be 1 distribution, and everything has a reason. You remember, you figure a strategy, you work backwards. We can bring this G down. 3 simplification, and we did that because we want to add a K. That would be 4 addition, and now we can get our L through 2, 5 modus ponens, okay? Let's make sure you get the P's and the Q's, because there is the P, there's the Q, there's the P again, and there's the Q, right? I saw that initially, breadcrumbs. That's how you get this L isolated, through modus ponens. So we needed to get P on a line all by itself, and the way to get P on a line all by itself is to use distribution on this to bring down the G through simplification, because I know distribution can turn this wedge into a dot. And then I just added the K. Okay, so first example, let's go to our second example here. Let's make sure we have the right ink. There we go. Okay, we need this disjunction we're trying to derive, either M or N, and I see M, N, and O, and because this is a wedge, you know, I'm thinking maybe disjunctive syllogism, but we need the M and the N together, and the M and the N are not together, the N's with the O, but you know, there is something we can do. Notice here you have wedge, wedge, so we can use associativity, right? And what if we change the parentheses and got M and N together and the O isolated? Then disjunctive syllogism, we're home free. So let's use associativity on the first premise, and we would turn that into, it's still a disjunction, main operator, either M or N, and see, that's looking like our conclusion a lot, it is, or O, and that'd be 1 associativity, okay, and all we did is move the parentheses. It does not change the truth, you know, the truth value of that expression. 4, now remember the logic Nazis. They want us to switch this around because we know we're going to use this not O with this expression here. Let's switch it. O, either O or M or N, right? So that would be 3 commutativity. And like I said, you know, I'm going to give you some problems. I'll say, don't worry about commutativity. You could use 2 and 3, and these cancel out and put the M or N down. But for right now, let's get you used to this rule. That's why I keep using it. So we've used commutativity on 3, and now everybody's happy in the logic world, and we can use 2 and 4 to get M or N, and that would be 2, 4 ds. Okay? So that's how that works. And then we'll do one more example here. Now, here's something I'm going to introduce I haven't talked about before. This is a pretty big conclusion, right? And sometimes if you look at this and you're not quite sure what direction to go, you can deconstruct this. What I mean by deconstruct is go ahead and replace this. Replace with more helpful expression. You know, interchange it. And so we know we can use distribution on this and replace this with conjunction. Now, I would have to, you know, the logic people would want me to, because G's going to come out and be one of the conjuncts, and F or B is going to be the other conjunct. So ideally, I'd have to use commutativity on each one of these. But to save time, I'm not going to. You guys all realize that that is equivalent to both G and F or B, right? Okay. So if we deconstruct this or interchange it or replace it with a more helpful expression, here is really what we're trying to derive. If we can derive this, then we can just replace this with that, okay? So we get some help by starting, you know, by doing something with the conclusion. Now, this does make it easier. If this is what we're trying to derive, well, G we can get by itself by just simplifying 2. So 2 simplification will give us G. Now all we need to do is get either F or B on a different line and we can just conjoin them, okay? So how would we do that? Well, this is the consequent of a conditional. If we can get K all by itself, we can use modus ponens, get this on a line, and then we conjoin them, and we'd probably have to use commutativity later on. So let's do that. So we're going to bring the K down, but let's do commutativity to make everybody happy. So 2, we can use, is both K and G is 2 commutativity. 5, let's bring the K down. That would be 4 simplification. And you see when we did this over here with the conclusion, all this becomes now is the breadcrumbs tell us get a G by itself, get an F or B by itself, and then conjoin them. Okay, so now we've got our K. We will use this with line 1 to get F or B, and that would be line 1 and line 5, and of course we used modus ponens. See, there's the P, there's the Q, here's our P, and there's the Q. Okay? Alright, so let's go to 7 here. So now we do have these let's bring them together, the two things. We can go both G and F or B, and this would be line 3 and 6, and that would be conjunction. And lo and behold, guess what we have? We have this right here, but this is our conclusion, so we have to go a step farther. So let's use distribution on this. It would be either both G and F or G and B, but we're not quite done yet. That is 7 distribution. And then 9, we're going to have to use commutativity, okay? So we could do it all at once, but logic people, if they wanted the long, you know, the way you're supposed to do it, we'd have to do it in 2 parts. So I'll do that. But if you had to use commutativity, I'd just let you do it all in one line. But let's just do it this way. We'd switch this, both F and G, either both F and G, or G and B, that would be 9. That would be 8 commutativity, but we only did one of them, and that's the axiom of replacement. We did part. Now let's do this one. Let's use commutativity over here. So it would be either both F and G, or both B and G, and that would be 9 commutativity, and we are done. Okay, F and G or B and G. So there you get a good use of commutativity. You do it in parts. I'm going to let you speed it up a lot of times. When I say don't worry about commutativity, you wouldn't have to do that in parts, and you wouldn't have to turn these around. You could just simplify a conjunction, even if the conjunct is on the right. Okay? Alright, so there's some more examples. I hope this helps. And our next videos, which will be the last for the course, will be on 7.4. The remaining rules of replacement, we'll call that videos Section 7.4, Rules of Replacement 2.